No, we're on now.
What?
Go.
Okay, so what I have here is a prototype of the BMS circuit that we recently made the schematic of, just to verify that it's working. I've got a power supply hooked up. It's sourcing 0.2 amps and is current limited. And I'm trying to keep the voltage of this supercapacitor bank at 2.5. So what I have here is power resistors shutting it off through a transistor controlled by the microcontroller. And here you can see the waveform as it, when this goes down, this is actually measuring the collector voltage on the transistor. When this voltage goes down, the current is being pulled off of the supercaps. And when it goes high, it's allowing them to charge. So you can see it's constantly regulating itself and switching back and forth to make sure that the supercaps stay around 2.5 volts.
Very cool. So what else? What are the rest of the parts of your...
So here we have an AVR Dragon, which we're using to program it, and here we have a C from Monolith Labs. This is actually Pixel Pulse, which Monolith Labs, it's a software released by Monolith Labs to be used with their C. It's very easy to debug circuits with, as you can see. It's similar to an oscilloscope, except much less expensive and really easy to play around with and, you know, poke around in.
Very cool, man. All right, so what are your future plans for this? Like, how are you going to scale it up?
Yeah, so right now we have it, this is the equivalent of one cell. So we want to make it so that each one of these microcontrollers can control up to 5 cells. And then once we have that, we're going to commit the designs to a PCB and then prototype, and then fabricate them. And
sounds good. Very cool, Matt. Thanks a lot.
Welcome.